Show that ABCD is a trapezoid and decide whether it is isosceles. In order to show that ABCD is a trapezoid, you need to find exactly one pair of parallel lines. To do this, find the slope of each line segment. So the slope of line segment BC equals 2 minus 3 divided by 3 minus 0, which equals negative 1/3. And the slope of line segment AD equals negative 3 minus negative 1 divided by 4 minus negative 2, which equals negative 2/6, which equals negative 1/3. And the slope of line segment AB equals 3 minus negative 1 divided by 0 minus negative 2, which equals 4/2, which equals 2. And the slope of line segment CD equals 2 minus negative 3 divided by 3 minus 4, which equals 5 divided by negative 1, which equals negative 5. So line segment BC is parallel to line segment AD, so ABCD is a trapezoid because there is exactly one pair of parallel lines. To determine whether the trapezoid is isosceles, you need to find the lengths of the legs. So AB equals the square root of the quantity negative 2 minus 0 squared plus the quantity negative 1 minus 3 squared, which equals the square root of 4 plus 16, which equals the square root of 20. And CD equals the square root of the quantity 4 minus 3 squared plus the quantity negative 3 minus 2 squared equals the square root of 1 plus 25, which equals the square root of 26. Thus the legs are not congruent and ABCD is not an isosceles trapezoid. ABCD is an isosceles trapezoid, and the measure of angle A equals 42 degrees. Find the measure of angle B, the measure of angle C, and the measure of angle D. Angle A and angle D are congruent base angles by the isosceles trapezoid base angles theorem. So the measure of angle D equals 42 degrees. Because the measure of angle A equals 42 degrees. Because angle A and angle B are consecutive interior angles, they are supplementary. Looking at the diagram, you know that angle A and angle B are consecutive interior angles because they both lie inside the parallel lines and to the left of the transversal. So the measure of angle B equals 180 degrees minus the measure of angle A, which equals 180 degrees minus 42 degrees, which equals 138 degrees. Also, angle B and angle C are congruent base angles by the isosceles trapezoid base angles theorem. So the measure of angle C equals 138 degrees because the measure of angle B equals 138 degrees. So the measure of angle B equals 138 degrees, the measure of angle C equals 138 degrees, and the measure of angle D equals 42 degrees. In the In the diagram, line segment MN is the midsegment of trapezoid PQRS. Find MN. By the trapezoid midsegment theorem, MN equals 1/2 times the quantity PQ plus SR. Substituting in the known values for PQ and SR gives MN equals 1/2 times the quantity 13 and 5/10 plus 18 and 9/10. Adding 13 and 5/10 and 18 and 9/10 gives MN equals 1/2 times 32 and 4/10. Simplifying gives MN equals 16 and 2/10. The length of line segment MN is 16 and 2/10 inches. Find the length of midsegment YZ in trapezoid PQRS. First, find the lengths of the bases using the distance formula. Notice that the bases of the trapezoid are side PS and side QR. So PS equals the square root of the quantity -3 minus -1 squared plus the quantity -1 minus -3 squared. Simplifying gives the square root of -2 squared plus 2 squared. Simplifying again gives the square root of 4 plus 4. Adding 4 and 4 gives the square root of 8. Simplifying gives 2 times the square root of 2. QR equals the square root of the quantity -1 minus 5 squared plus the quantity 3 minus -3 squared. Simplifying gives the square root of -6 squared plus 6 squared. Simplifying again gives the square root of 36 plus 36. Adding 36 and 36 gives the square root of 72. Simplifying gives 6 times the square root of 2. By the trapezoid midsegment theorem, YZ equals 1/2 times the quantity PS plus QR. Substituting in the lengths for PS and QR gives YZ equals 1/2 times the quantity 2 times the square root of 2 plus 6 times the square root of 2. Simplifying gives YZ equals 1/2 times 8 times the square root of 2. So YZ equals 4 times the square root of 2 units. Find the measure of angle C in the kite shown. By the kite opposite angles theorem, ABCD has exactly one pair of congruent opposite angles. So because angle B is not congruent to angle D, angle A and angle C must be congruent. So the measure of angle A plus the measure of angle C plus 80 degrees plus 50 degrees equals 360 degrees by the corollary to the polygon interior angles theorem. Combining like terms on the left side gives the measure of angle A plus the measure of angle C plus 130 degrees equals 360 degrees. Subtracting 130 degrees from each side gives the measure of angle A plus the measure of angle C equals 230 degrees. Because angle A and angle C are congruent, you can substitute the measure of angle C for the measure of angle A in the equation, which gives 2 times the measure of angle C equals 230 degrees. Dividing by 2 on each side gives that the measure of angle C equals 115 degrees. What is the most specific name for quadrilateral JKLM? From the diagram, line segment JM is parallel to line segment KL and JK equals ML. You do not know whether or not the parallel sides are congruent or that the congruent sides are parallel. To classify the quadrilateral as a parallelogram, the parallel sides must be congruent or the congruent sides must be parallel. Because you do not know this information, you cannot call the quadrilateral a parallelogram, which means that this quadrilateral cannot be a rectangle, rhombus, or a square. In order to classify this quadrilateral as a trapezoid, you would need to know that the parallel lines are not congruent. So the quadrilateral cannot be classified as a trapezoid. And you cannot classify this quadrilateral as a kite because you have a pair of opposite sides that are congruent. So the most specific name for JKLM is a quadrilateral.